Okay, so let's continue with the problems. In this case, we're going to be working with problem 65, page 102, still section 2.4.2.1. So this is problem 65. And let's read the statement of the problem. Sarah Beth made annual deposits of $5,000 in an account that paid 4% compounded annually. How much money should be in the account immediately after the 10th deposit? Okay, so we have that the annuities that she's depositing are each of $5,000. The interest rate is 4%, and the number of periods is 10. So the formula that we can use, we're interested in knowing the final balance at the end of 4 periods, at 10 periods. So that's the future value of 5,000, which are annuities, times F, given that we know the annuities at 4% interest rate and we have 10 of those annuities. The computations associated to that are 5,000 times 1.04 to the 10 minus 1 divided by 0.04. That is, the future value is 5,000 times 12.00610. The future value is then $60,030.53. Okay, now we move on to problem 67. Let's read problem 67. Adriana wishes to accumulate $2 million in 35 years. If 35 end-of-year deposits are made into an account that pays interest rate of 7% compounded annually, what size deposit is required each year to meet Adriana's stated objective? So from this statement we gather that she wants to accumulate, this is problem 67, and she wants to accumulate in the future $2 million, and in order to achieve that she has 35 years and the interest rate is 7% per year. So the question is how much should deposit each year, and that means that she's looking to compute the annuities. She's going to be making 35 annuities, and the question is how large those annuities should be. So we have to compute A, given that we know that the future value, that should read the future value compute the annuity given that we know the future value is $2 million, the interest rate is 7%, and we have 35 periods. So this is equivalent to 2 million times, and using the formulas we have 0.07 divided by 1 0.07 to the 35 minus 1. Or simply $14,467.91. That is, she needs to save at the end of every year $14,467 in order to be able to collect $2 million at the end of 35 years. The last problem we're going to solve in this video is problem 77, and we're only going to concentrate on A because it's a rather longer problem. The statement says, in planning your retirement, what would you like? Would like to withdraw $60,000 per year for 10 years. The first withdrawal will occur 20 years from today. Now here is very important to count the number of periods, and for that I'm going to make a diagram. In the last years we want to be able to make 10 withdrawals. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 withdrawals. I hope that's right. So this is the 10th. 9, 8, 7, 6, 5, 4, 3, 2 and 1. Now in the statement of the problem, this first withdrawal happens 20 years from today. The question is, how much do we need to invest today? And that happens, this period here is the 20th year from today. So that means that you're going to make a deposit here and you only have 20 years to get to that point. Now the interesting part is that given the models that we have to compute these quantities, when we made the computation about all of these, we're going to act, when we compute P given A with respect to these A's, each one of these A's are $60,000. Then we're going to bring that quantity back to say the equivalent to 0 here, but that equivalent to 0 here is actually, this would be the 19th year. So actually you only have 19 years from 0 to 19 to collect the money, because after that you will have to use, here you're using the model P given F, P given A, or A given P, and for this part of the model you're going to be using P given F. So in order to solve this problem, we need to take into consideration that the annuity is $60,000 for the retirement, and the interest rate is 10% for the problem A. And just solving the first part would turn into solving $60,000 times P given A, 10%, we have 10 annuities, but that will bring the quantity back to period number 19, so that would be the relative present at t equals 19. But what we really need to know is the value of, or the amount of investment at t equals 0, so the present value at t equals 19, we still need to bring the money from the future back on t equals 19, so that would be the previous result we got as the relative present at t equals 19 as P given F multiplied times P given F 10% and 19, and the final answer when the interest rate is 10% is $60,281.15. So that's the value that we get when we use 10%. Compare that to the value that we have when we use 5%. With 5%, you would need $183,345. So this is a very similar problem to what might come in the test, in which you actually need to make good computation on the number of periods that you need in your model. Remember that the fact that when you use P given A, the first annuity happens one period after the present value. If you have any questions, please contact me. Thank you.